Okay. So the first form of linear function is standard form, and it looks like this: ax plus by equals c. And what is a and b and c over here? A and b and c over here is just constant. What I mean over here is just number. A, B, and C could be a whole number, could be a fraction, it could be negative, it could be positive, it could be a radical number if I want it. Okay? X and Y is just a variable. That's why we call it two variable form. Two variable, because X is a variable, Y is a variable. You know what you learned last time when you learned function, right? You learned that X is input and Y input. So that's what it is. Okay? I can give you an example like this. 2x plus 3y equal 4, for example. Alright, you look at this and you see this, and you look at, if you see in this form, then you know right away that this is the linear equation, the linear function in two variables. Okay? Or I can have fractions. I can have 1 over 2x minus 3 over 4y equal negative 7, for example. This could be, this is also linear function, or linear equation in two variable. Okay? Or I can have radical if I want to. Radical 2x plus radical 3y equal radical 5. Same thing. It's also in the form your a over here is square root of 2, your b is square root of 3, and your c is square root of 5. Okay. And I just said the linear function represents a line, right? Okay. So in order to get the line, we just need 2 points. And one of the best ways to grab any function is just go ahead and set up the table. Like last time, we set up the table, and you let x equal to 0, then 1 or 1, and you try to get the y value. So as long as you get a different point, then you connect all of them, right? So let's see what we can do for this one or not. Okay? So let's try to graph this. Alright. So this is your y, this is your x. Alright, so I'm going to set up the table. Okay, I'm going to set up the table. Because we use the traditional way to graph. Later on, we're going to use another way. Okay. Okay, so this is your x here, right? This is your y here, right? Let's see which one. I think I'm going to change a little bit over here. Let's change this to 6. I think it's easier. Let's change this to 6. Easier to do. Okay. Now I'm going to let x equal to 0. Alright, so if x equal to 0, what happens? So I'm going to put 0 into the x, right? So let's put 0 into the x. So you have 2 times 0 plus 3y equals 6. Right? Okay, y equals 6. And 2 times 0 is just 2 times 0 is just 0. So what you have left is 3y equals 6, right? 3y equals 6. And y equals what? 2. Y equals 2. Exactly. Y equals 2. So y equals 2, right? And so if x equals 0, y equals 2. Let's go ahead and locate it on the coordinate system over here. So 0, 1, 2. Here you go. It's right up here. One of the points is right there, right on the y-axis. Now let x equal 1. Let's see what happens. Okay, x equal to 1, so I'm going to do over here. 2 times 1 plus 3y equals 6, right? I just x put 1 in. 2 times 1 is 2 plus 3y equals 6. Right. And that's a nice number either. So subtract both sides by 2, so you have 3y equals 4, right? And y equals 4 over 3. over 3 is about 1 1/3. So, oh, I think I'm plugging in something wrong, right? Oh yeah, that's good, that's good. So, when x equal 1, so x equal 1 over here, y equal 4 over 3, 1 1/3, so it's about right here. It's just kind of estimation. Doesn't have to be perfect. We try to, but doesn't have to. Alright. So you got 2 points. As long as you get 2 points, you can have the line. So go ahead and get the line. There you go. Right. Alright. There you go. Good. Now if you notice the line I have over here is intersect the y-axis at this one, and it intersects the x-axis at this one, right? Those 2 points, they have name. We call that X-intercept point. Now remember last time we were talking about function, I gave you an example how to find x and y-intercept. Okay, so basically x and y-intercept is the intersection point between the graph, the line is a graph, and xy axis. So this is y-intercept. Okay. And remember how to find x-intercept and y-intercept? Anyone remember? Let's try to find the coordinate of this point. Actually, the coordinate of this point is already there, but I just want to ask you again how to find the coordinate of x-intercept point. Anyone? Okay, you put y equal to 0. How about the y-intercept? Y equal to 0. Okay, so let's redo that again over here for this linear equation, okay, linear function. So let's find x-intercept point. So this is the concept we learned last time. Okay, so I'm going to replace y with 0. So it's going to become what? 2x plus 3 times 0 equals 6, right? And we have 3 times 0 is 0, so you have 2x equals 6, x equals 3. Are we going to stop right over here, or is this good? Or are we going to do something else for the x-intercept point?
You have to make it coordinate.
You got to make it a coordinate or the pair form. If you leave it like this, it's not a point. This is called x-intercept value. Okay, when I say find x-intercept point and y-intercept point, you have to put in order pair form, which is the coordinate. So the coordinate over here will be 3, comma 0. And for the y-intercept point, I already got it over here. Okay, so this is y-intercept point. Okay. And the coordinate will be 0, 2. Okay, 0, 2. Good. So far so good. Kind of very straightforward. No trick over here. Alright, on the second form of linear equation, linear function, we call that slope-intercept form. Slope-intercept form. So slope-intercept form is y equal to mx plus b. So this is slope-intercept form. And y is equal to what? Last time we already learned function. Y equal to what? Y equal to what?
mx plus b.
What's that?
mx plus b.
Yeah, that's the slope-intercept form. But I'm talking about what is the y. Y we can replace with something else. So we have f of x equal mx plus b. So every time we talk about linear function, basically this is, they barely talk about this form. When we talk about this form, when we try to write linear equation, but every time we talk about linear function, this is the form right here. And basically, this is kind of the same because I can convert this to this, and we have another form, which is I think I'm going to introduce you today also. Yeah, we have another form. And based on all of those three forms that can relate to each other, they can convert from one form to the other form. So this is f of x equal to mx. So this is linear function right here. Let's try to understand each variable here. The letter m, we call this the slope. And the b, we call it the y-intercept value. Y-intercept value. Now let's talk about the slope. The slope can tell you if the line is increasing or decreasing. What I mean over here, it can tell you if the line is slanted upward or slanted downward. For example, in this case, alright, the line kind of go downward over here. If the lines go downward like this, the slope will be negative. Okay? If the line goes upward like this, then the slope will be positive. Okay? So over here I'm going to put into two cases. If m positive, we know that the line is slanted upward. And if m is negative, we know the line is slanted downward. And no matter what is slanted upward or slanted downward for any linear function, because it's a line, we already talked about the domain of that. Okay? The domain of any line, of any linear function will be what? Anyone can give me the domain of this line over here? Negative infinity to positive. So the domain of any linear function, I'm going to add over here domain, will be negative infinity to positive infinity. How about the range? How about the range?
Same.
Same thing. Same thing. Well, unless I want to put the restriction on that line. If I don't put the restriction, I just keep it extended. If the line keep extending to both ends like this, then the domain and range will be negative infinity to positive. Usually in high school, they put the arrow like this, I remember. But you don't have to put arrow in college anymore. You just know, all right, this is going up and the other go down, Okay. All right, let's talk more about the slope. So the slope tells you how slanted it is. It can tell you the change of y over the change of x. So the slope, they have another name. We call it rate of change. So m is also the rate of change. Okay, which is, okay, this means in other words, okay, change of y over change of x. Okay, change of y over the change of x. In high school, we usually call that rise over run. Rise over run. Okay, rise over run. And And the change of y over the change of x, we can rewrite it as, y2 minus y1 over x2 minus x1. And what is y2 and y1, x2 and x1? y2 and y1 is actually a point on the line. So it will be the point x1, y1, okay, and point x2, y2. Okay. It means what? It means that if you have a line and you pick 2 points on the line, and you know the components, you know the coordinate of that point, we can find the slope of the line easily by applying this formula. We call the slope formula. Okay. Of course, we can find the slope by using rise over run method too. And we're given a graph. We look at a rise over run method. How are we going to do that? Let's go through the example here. Example number 1 for this point. So let's try to find the slope of this picture right here, okay? Of this graph right here. So I know this is we don't know. Okay, so the x-intercept over here will be what? It's 3. Okay, so I'm gonna try to find the slope over there by using rise over run method. Okay, that's it. In order to use rise over run method, you always start from the y-intercept point. So over here you have to start over here. Okay. And you want to go to this point, which is the x-intercept point. Okay. Let's see how many units you go down. You go from here to here, right? 2 units, right? Then you go from here to here, 3 units. If you go down, you put negative. So your slope will be -2. Okay. Going to the right, positive, will be 3. Okay, will be 3. So over here, I just want to put a remark right here, just in case you forgot. Go down, going down, all left. Okay, it's going to be negative. Okay, and going up or right will be positive. So this is the rule when you use rise over run method to find the slope. Okay.
Does that say remember? Or
The remark.
oh, remark.
Yeah, remark. What is it? My handwriting is that bad?
No, I just can't see from.
No, that's okay. Actually, that's my sister keep complaining about that, about my handwriting. But I mean, I try to be really careful, no matter what I do. Even though my handwriting sometimes is not really good, but when I write math, I write carefully. So that's what I want you to do. Sometimes your handwriting is good and that's perfect. If your handwriting is not good, you try to write carefully. Then everything will be fine. Okay. Remark. Okay. So that is how you find the slope of any line using rise over there. You always start. Okay. I'm going to add over here a little bit over here. Always start. Okay. At y-intercept point. Actually, I should put this before this, though. So this is put it up here. Any questions so far? Good. Now, I'm gonna give you another example, but now I'm not gonna use the rise over run anymore. Let's see if we can find a slope by using the slope formula now. But in order to do so, we must have the point. Okay, so on example number 2, over 2. Given 2 point, given 2 point. Let me know if it stop, okay? Given 2 point, the first one I call it point A, the coordinate is 2, 5. And the second point I call it point B, coordinate is negative 4, 6, for example. Okay, now I want to find slope. Finding the slope is super important, I can tell you that. Super important because if you cannot find the slope, then you cannot write linear equation. You cannot write linear function anymore. Okay, so let's see. It's not really that hard. Alright, let's put m, right? M in the slope, the modulus. y2, the slope formula is here, y2 minus 1 over x2 minus x1. So let's level them. So this x1 right here, y1 here, x2 here, y2 here. Alright, so you know where x1, y1 already. Just go ahead and plug them in. Okay, so y2 minus 1. Let me rewrite the formula. X1, y2 will be 6, alright? Minus what? 5. Over x2 is minus 2. So it'll give you 1, just negative 1 6. Okay. So in order to find the slope, you must have the coordinate of 2 points. At least 2 points. Without the coordinate, you can't. Okay? Or they give you the graph, and you can find the slope by the rise over run method. Either way. Okay? Any questions so far on the slope and the rise over run? The b-intercept, let's talk about the b-intercept value. The b-intercept value is actually whatever right here. Whatever the value where's the line intersection the y-axis. So that's the b, the y-intercept value. They always use b. Okay? I don't know why. It could be any letter if you want to, but this look like it's B is kind of standard notation for this. Okay, so people always say y equal to mx plus b. Nobody say y equal to mx plus w, right? But actually, you can put a w over there if you want to, as long as you understand your w is this. It's not really a big matter with those letters, as long as you understand it. Okay? And the m is the standard notation, so m the slope we have to use m. Because actually, the m over here is come from the word modulus. Okay, so we have to use m for that. But again, some textbook when we're dealing with application of linear function, well, they don't use m either. They probably use that as fx equal to cx plus t. Well, that's fine, as long as they understand it. The c is the m, the c is the slope. So the letter is not a big matter, okay? It's not a big problem. You have to understand it, the letter only. All right? And the next form, it should be the last form. I'm gonna just go ahead. I really don't want to delete this yet. Let me see. I think I'm going to delete this. Number 3. Next form is called a slope intercept form. Slope intercept form.
Is it meant to be the same thing as number 2?
What's that?
It's the same thing as number 2, is it meant to be?
Same thing as, no, this is, oh, I'm sorry. Good job, good to point that out. Okay, punch slope form.
Oh, okay.
So that's for third. The next form is point slope form. Okay, what does point slope form look like? Of course, it is going to be related to the slope. Okay, and it's related to a point. So in order to write that equation, okay, you must have a point. Given a point, and the point over here with coordinate is x naught, y naught, x zeros, y sub 0. Okay, and the slope, n. Then your equation will become y minus y0 equal m times x minus x.
So it's not like y1 and x1 because, like, I know in high school I learned to like.
Well, again, you can change it. Y1, x1, that's fine.
Okay.
As I said, it's just the name. You can put like ST, whatever you want to, but you have to understand that that is the point. So yes, in your high school, usually y1, x1. You can use that, that's fine. Okay. Okay. So for example, I have a function like an equation like this. Y minus 2 equal 3x minus 1. And you look at that and you know right away this is linear equation. Okay. A linear function. You look at this, you know right away this is linear function too. Or you look at a standard form, you know right away this linear function too. And all three those forms right there is kind of related to each other. Immediately we can convert from one form to another form. How? So I have a point slope form right here. Let's see if we can convert this to standard form. What is standard form again? Ax plus by equals c. Alright. Let's see how we're gonna do this, okay? Let's work on this together. So I'm going to convert this to standard. Okay. Ax plus by equals c means your x and the y must be one side and this number must be on the other side. So the first step you have to do is you're going to go ahead, distribute number 3 in. Okay, distribute number 3 in. Then, you see, ax plus by equals c. Ax plus by is on the same side. Right now, your y on the left side, the ax is still on the right. So you're going to move this over here. So how am I going to move it? Anyone? Subtract both sides by 3x. So you have negative 3x plus y minus 2 equal negative 3. Right. Now go back to the form again. Ax plus by equals c. So look like that. What is your a over here? Your b is c must be on the right. So how am I going to move this? You add it. I'll give you negative 1. That's your c, negative 1. See, from the point slope form of the linear function, I can bring it to standard form. Easily. Super easily. Even if it's in the slope intercept form, it's even easier. I really want the other student coming back so that I don't have to do this. But I don't know when exam will do. Alright. So I'm going to give you a slope-intercept form, okay? Y equal negative 1 over 2x plus 3 over 4. Now I'm going to try to convert this to standard form. Anyone can tell me what is the slope over here?
Negative 1.
What is the b value? 3 over 4. Which means that the line of this graph, the graph of this line is going to cut the y-axis as 3, 4. Slope is negative 1 over 2. Alright, standard form ax plus b y equals c. We don't have any, we try to avoid a fraction. Okay? So I'm trying to get rid of the fraction over here. Try to get rid of the fraction. So what I'm going to do, I'm going to multiply both sides by 2 to get rid of 2. So I'm going to have 2y equal negative 1 over 2 times 2, right? Let me do step by step. Okay. 3 over 4 times 2. So you see that this 2 and this 2 cancel out, so you have 2y equal negative x plus 2 simplify with 4, or you can multiply this to give you 6 over 4. You want to. Anyone can help me get rid of number 4 over here?
Don't you times it again?
Yeah, time it again. Multiply both sides again by 4. So give you multiply over here by 4, give you 8y. But make sure that when you say multiply both sides, I mean you multiply everything, okay? Multiply by 4 here, negative 4x. Multiply by 4, you cancel out, 6. Okay? Is it in the standard form yet? Is it in the standard form yet?
No.
No.
You have
You
to
got
add
you have to add 4 hand.
Oh.
There you go. You can simplify by 2 if you want to. You can leave it like that. Doesn't matter. Remember, the standard form is the x and the y must be on the same side. Okay, the number on the other side. If the x and the y are on different side, then you have to do something so that you can bring it on the same side. Good? Alright, let's see. So we talked about point slope of linear function, standard form, the slope-intercept form. For the next section after the test, we're gonna cover more about this point slope and the slope-intercept. Right now, at this moment, it's just kind of introduction, for you to know what it looks like for every linear function. Let me see. So I think that's it for the concept. I'm going to give you something to do. Then I guess we can be dismissed to prepare for the test. Let me see. Okay. If you have any question regarding homework, you can bring it up too. Okay. Let me see. I can find something over here. So we just finished 3.3. Everything is kind of very straightforward. The only thing that probably you have trouble over here is this. So I'm gonna let me give you another example. So I want you to do it yourself. Just want to make sure that you guys know how to convert from slope intercept to a standard one. Okay. So let's jump to example number 3. Kind of the same question. So I have this y equal 4 or 5x plus square root of 2. There you go. Go ahead. Try to convert this to standard form, okay? Alright, go. I'm going to find something here. Equation 3. So when you're doing homework and you see anything related to parallel and perpendicular, don't do that, okay? Just let me know, okay? Because that is the concept we're going to do after the test, okay? We can just leave it there. Try not to do something with parallel and perpendicular, because that's one of the property of the line. Alright, so I had fraction. Go ahead, get rid of the denominator here by what we're going to do? Multiply both sides by 5. So 5y equal to -4x plus 5 square root of 2. Right, 5 square root of 2. Well, you don't have to convert it to decimal, just leave it at it. And now, is it in the standard form yet? No, we're going to move what? 4x. So 4x plus 5y equal 5 square root. That's it.
5 square root. It's not square root of 10?
Oh, no.
So it's not
5, no. 5 square root of 2 is 5 square root of 2. It's not square root of 10.
I'm sorry, y'all.
We cannot do that. Okay. 5 square root of 2 is 5 times, actually square root of 2 is 1.41 something. So it will be 5 times 1.41. But if you do square root of 10, it's not 1.41. Alright, any questions so far before we get to the final concept? So this is the next one. The next number will be the 4th one. Okay. Number 4. Number 4, I want to talk about special line. All right. But how special is that? How special is that? Okay. I want you to look at this form right here, the slope-intercept form. Okay. Now, what if I have the slope over here? Okay. What if I have the slope over here is 1? Okay. And Let me see. And I have the B over here is, let me see, should I start from this, or I think we should start from the standard. So let's start from the standard form. I think that's better. I have AX plus BY equals C, instead of starting from slope-intercept form. Now I'm going to go ahead and solve for, so Y when A equals 0. So let A equals 0. Okay, let A equals 0. Then my equation becomes what? 0 times X is just gone. So you have BY equals C, right? And in order to get Y, you get divide both sides by B, so C over B. If you see a linear line, and that is in this form, this is horizontal line. Horizontal line. Okay? For example, I have Y equal to, if Y equal to number, it's horizontal line. Okay? Is Y equal to this look like this? I have a line like this, a coordinate system like this. Okay? So we have 1, 2 is here. So the line Y equal to is actually this.
Oh, okay, I remember this.
Okay, no, ring the bell, huh? Can I get back to you? Okay. Now, any questions so far? So, if you have an equation, you start with Y and equal to number, then it's always horizontal line. Okay. Now, what happens if I let B equal 0? Let B equal 0. Then what you have? If B equal to 0 and you plug over here, so what do you have?
So wouldn't the line go like straight down?
Straight down, yeah. But let's plug over here first. So B equal to 0. So 0, everything here, right? So you have AX equals C. Then X equals C over A. Alright, so this is vertical line. Vertical line. Okay. Alright, example. What if I have X equals 3, for example? Alright, so you have something like this. Y over here, X here. Okay. And Y equals 3, Y equals 3 here. 1, 2, 3. Oh, X equals 3, I'm sorry. X equals 3, 1, 2, 3. So there's X. And it's always vertical line. Okay, my line's not good, but let's try to. Okay. Vertical line always perpendicular to the X. Horizontal line perpendicular to the Y. Okay. Any question on those special line? Well, actually, the textbook in section 3.4, which is the not 3.4, 3.3. Let me see. I just want to check that if they talk about perpendicular and parallel or not, because I just say that every time if you see that you just don't do it, just let me know, okay? But let me check one more time here. Yep, so I think, yep, that's all we have for today. Okay? Any concern, any question for the test? Actually, it's at home, so you guys should be okay. Try to help each other, okay? I mean, if you get stuck, I don't mind at all, but just make sure that I don't copy the wrong one. photocopy the wrong one, and try to do it yourself first. Try to do it yourself first, then you compare your answer with your friend, then you go ahead and submit. Make sure that you submit in PDF, okay? Don't ever send me the JPEG. JPEG, I cannot grade it. Alright? Again, no class on Tuesday next week, okay? I'm going to send you guys an official announcement. So waiting on my email, okay? Alright.
Right, I still have psychology.
Because my anthropology class starts next week, so we're not meeting on the first day.
No, I think like